Hi, in this lesson we are going to learn about multi-dimensional arrays. We will look at two-dimensional and three-dimensional arrays in theory, then we will understand how the memory is allocated to these multi-dimensional arrays. The same concept can be applied to multi-dimensional arrays with depth 4 or 5 or even more. Let's get started. In Java, arrays are objects, right? We have seen arrays of primitive types. Also, we have seen arrays of reference types like array of strings, array of dates. These are also called array of objects. And also we have seen how the memory is allocated to these. But let's recap how the memory is assigned to primitive types, reference types. And then we will look at how the memory is allocated to array of primitive types and array of reference types. Here, a variable of type integer is defined. So the memory will be allocated for this variable. Because integer is 4 bytes, memory will be 4 bytes. Then when we assign the value of 10 will be saved in this memory location. That is how primitive variables works, right? Now let's look at reference types. We are creating a reference type of date. So the memory will be allocated for date reference. Then we have to create a new object, and again memory will be allocated for this object, and the memory location will be saved in the variable. So that is how the variable is referring to the object. So this is the memory diagram for simple variable of primitive type and reference type. So in case of reference type, there are two memory locations, one for reference variable and another for the object. So the memory for this object will be available as long as any reference is referring to this object. Once there are no references to this object, garbage collector will remove the objects and will release the memory. Okay. Then let's look at array. Okay. Arrays are objects in Java. So here first for the variable of array, here array of integers, right? For the variable the memory will be allocated, then the object or array will be created and address of that array will be saved in the variable. So it is similar to the date object we have seen previously. So this is how integer array will be created. Then we have seen how the array of strings will be created, right? So here array of strings is of type array of string. So array of strings is the variable name. So that is the confusion here. So here the variable will be allocated address. Then the array will be allocated some memory. Then manohar and academy. These are two strings. In Java, strings are objects. They are not of primitive type. So they are also objects. For them also memory will be allocated. So the right hand side you can clearly see the array of strings has 3 objects, not just 2 objects like array of primitive types. Here we have one array that is referring to 2 objects. Okay. So this is how memory will be allocated for array of reference types. Let's go further. This is what we have seen in the previous slide. So here string is a object, right? String is a reference type, and here manohar is a object, academy is a object of string type. So also arrays are objects. So can I replace string with array of integers? Because array of integers is a object, string is also a object. So let's do that. Let's replace string with array of integers. Okay, both are objects. So here if you see, I just replaced string with array of integers. Also I replaced manohar with a array of integers, academy with array of integers. So this is how we will form two-dimensional arrays that are having primitive values. Okay, so from this one, by comparing array of strings with array of integers, we can clearly understand how the memory is allocated for these arrays. If you have any questions here, please go back to the previous slide and try to understand this. This is very important. We need to understand how the memory is allocated for these multi-dimensional arrays. Okay, here if you see, even though here there is an array, here there are arrays, only the last ones will be having the values. Here 1, 2, 3, 4, 5. These are the values of type integer that are being saved in this array. So only the last level of arrays will be having these values. Here we are looking at a 3D array or 3-dimensional array. First here, if you see here, we have a 2-dimensional array. This is a 2-dimensional array, right? Then we have one more 2-dimensional array. Then if we make an array of these 2-dimensional arrays, then it is going to become 3-dimensional array. So this is how we represent 3-dimensional array. After int there will be 3 brackets. Okay. One of them is not looking properly, but this is also bracket, only square bracket. So the number of square brackets here the pairs, I mean the number of pairs of square brackets here is going to decide the depth of this array. Here it is 3-dimensional array. Let's see how this is saved. So if you see here, first array is having 2 elements, right? Outermost 3-dimensional array is having 2-dimensional arrays. So here I simply mentioned A for the address instead of mentioning this 500, 600 and all those values. So here this array is nothing but pointing to these 2-dimensional arrays. Let me highlight. Okay, this array is basically to point to these 2 arrays, this one and this one. So if you see here, the outermost array is having 2-dimensional arrays. So this is the outermost array and it is referring to 2-dimensional arrays. These are the 2-dimensional arrays. So this is the first one. It will go here. This is the next one. So it will go here. So similarly for the second one, 6 and 7 goes here. This goes here. So this is how 3D array or 3-dimensional array is saved or memory is allocated. So here what we are looking at is array of arrays. So that is how it is 3-dimensional array. Here also if you see the actual values, that is 1, 2, 3, 4, 5 up to 10, these are saved at the last level only. This is the last level, right? So intermediate arrays. So this one and this one, these are intermediate arrays and they are not saving any values. They are only pointing to the last, I mean in this case 3rd-dimensional array. Okay, so this is also called ragged array because here if you see, they are not of equal length. So here it has only 2 elements, here it has 3 elements. So because of that it is called ragged array. Okay, so in Java you don't need to have the same length for all dimensions. So you can have a ragged arrays. This is possible because here we are having arrays of arrays. Okay, in this case 3-dimensional array, so it is array of integers. Okay, so we can have even 4-dimensional arrays, 5-dimensional arrays or any number of depth. There is no limit actually, but anyhow no one will be going to 10-dimensional array, something like that, right? Even 4-dimensional array itself is difficult to understand and see that. So this is the theory behind how the array of arrays or 2-dimensional, 3-dimensional or whatever number is the dimension arrays works. We need to understand without any doubt how the memory is allocated. Okay, so go back to these slides, replay these slides and then you will be able to understand how these are saved. If you want, I can play the animation once again. Okay, let me play that. Here we have primitive type, just memory is allocated, whatever value we assign will be saved. Then here we have reference type, memory for the variable. Then we have to create an object, memory will be allocated for object and the variable will be referring to that object using the memory location. That is about primitive variable and reference type variable. After that we have our arrays, we have integer array. So variable is having memory allocated, then array will be created at so and so address and the variable will be referring to that array. Next we are seeing array of reference types. So in this case string. So memory will be allocated for the variable and array will be created and this array has to point to 2 objects. So 2 more memories will be allocated for the 2 objects. So in the next example we are looking at the 2-dimensional array by converting this string to array of integers. So that is how 2-dimensional arrays will be saved. With this knowledge we are going to look at 3-dimensional arrays. In this case we are also looking at ragged array because the last elements, they are not of equal length. So very easy to understand once you are able to visualize this diagram. Okay, thank you for watching. Please subscribe and share it with others. Thank you.